Hey guys, today's problem is regarding the partition array for the maximum sum. Okay, so let's read the problem. It's a medium problem. Uh, Given an integer array and partition array into contiguous subarray. The thing is, particularly you have to note that is the contiguous subarray. Okay, for the length at most k, in which it means that I have to make a subarray of at least no at most k, or it can be at least one, like simple one or two or three. Okay, simple subarray. Now in the situation is, if I divide a subarray, then all the value will be replaced by the maximum subarray, maximum value. Suppose I take the, let's take the example that I can elaborate. Okay. Suppose I have this value 1, 15, 7, 9, 2, 5, 10. So I have to divide this array into such a form that the resultant value will be maximum. Okay. And one thing would be should be a k value. K, suppose I have 3. So I can divide this into one array, into one subarray, and into one another subarray. Okay, so it will convert it into 15, 15, 15, because it is a maximum value, so all will be replaced. Okay, in this same 9, 9, 9 and 10. Okay, 15, 30, 45 and 27 and 10. Okay, then this 5, 82. In my way, the sum is 82, but we have to find the maximums. It will giving a 84. Okay, so I'm just telling you how to we can. Okay, so let's give you a scenario in which I don't know basically in which portion should I cut this array. I can cut into this portion also. I can cut the array into this, and there is many ways. So if there are many ways, so the simple approach will be a recursion. We can do a recursion in which we can choose accordingly what we have to do. So, okay, so suppose I have 1. So if I have 1, so I can divide this into 1 or 1 comma 15 or 1 comma 15 comma 7. Okay, this could be the probability, this could be the trees. Now further I can do is I have 9, so I can take 9, 9 comma 2 or 9 comma 5. No, sorry, 9 comma 2 comma 5. Or further I can take as 2, 2 comma 5 or 2 comma 5 comma 10. So if I take this optimal ways, it would be this, okay, this and this. So it will give 45, it will give 9, okay, and it will give 30. So 30 plus 45, 75, 75 plus 9, 84. Okay, we got the answer. This is the main approach, so we can do this. Okay, so how can we code this up? So we have to simply code this. Okay, now we have to do a recursion. Okay, so let's code this. We have to do the recursion. So let's find the length of the array. Then we can do is make a function. Okay, and in which I'll give index I. Now if let's define a base condition in which if I equals to n, then return 0. Okay, so basically I'm going to do this, and to store all the results I'm going to use a res in which I'm going to return res. Okay, now the thing is, no, simply see this. I means we are on the starting point of the subarray. Okay, in which I this, if we are on this, then this is starting point. So from this we have to make a subarray. Okay, we can make subarray like this, we can make a subarray like this, or we can make a subarray like this up to k. Okay, so let's do a for loop for ending. Let's make it e in range I comma I plus k. Okay, so in which I have to check the maximum of all these and make a sum. So let's define a window, which means it means the length of the sub array we are forming. Okay, window means this, and max of subarray. This will tell me what is the maximum of the sub array. Okay, simple this. So let's define this. So the max of sub would be the max of sub comma the array e. Okay, so we are going like this, in which I'm going to use this portion, then this portion, then this portion, in which I'm going to use this portion first, then this portion. Okay, this is main thing. Now let's increase the window size also. Okay, so we have find the maximum of the subarray. Suppose I have the subarray like this, so the maximum would be 15. Okay, so it will be stored in the maximum of sub. And then what is the size of this? It is 3, so the 3 will be here in the window. Okay, so I have find this. So let's do a recursion call again. Do a recursion call to find the next subarray. Okay, now suppose I have to find this, so that I can call the more. Okay, so res would be the max of res comma window into max of sub. I did this because suppose I have 3 values, 1, 2, I have 1, 2 and 3, and if I found the value maximum is 3 and the window size is 3, so 3 into 3, 9, so it will give the sum of this all. Okay, so I did this, and I do a recursion call on e plus 1. As I have found the e, then I can do a e plus 1, and that's all for this code. And now I can return the value. Now let's run this. It's showing me oh, out of index. Now I have to find if e is equals to n, break. Simple. As suppose I am in this position and I'm doing I to I plus k, so the index would be nothing. So I'm using this. So it's accepting. So let's do. It's give me a TLE because I'm doing a recursion call all the time, so it gives me TRE. I'm sure of that. Yeah, it's giving me a TLE on the 14th. Okay, how can I optimize this? Suppose if I have find the value, I can use a cache value. Okay, I can use a DP in this memorization. Let's code this. Now memo. Okay, so how can I do this? Doing a DP, and if I in DP return DP comma I equals to rest. Now these three lines, just 1, 2 and 3, will make me submit the problem. Oh, sorry. Yeah, it will make me submit the problem because I'm just saving all the values in the DP value which I have calculated first. Now I have done the memorization. Let's try for the tabulation. If you want to see, then you can further watch the video. Okay, now let's cut this and let's make it new. Okay, now suppose I have some values. Okay, now in the memorization I was doing just finding, I was in this position and doing a recursion call on these. Okay, so now in the tabulation we are doing just a reverse of this. Okay, we are just going to reverse of this, in which suppose I am at this position, then I am going to find which is in, this is going to be ending, this was the starting. Now in the I means this will be ending, and I am going to find which k till k. Suppose k is 3, so I can use this. Okay, I can choose these two values accordingly. Okay, this is all the concept behind this. Nothing fancy, nothing good. Okay, so let's put in a memo function just to save this. Nothing, I can even delete this code, no worries, but for the better to understand you, let's do the table. Okay, now let's do the tabulation. So I told you to make a DP of 0 into n, where n equals to length of array. It will just create in this it will just create a DP array of in which create DP array, in each value it is 0. Okay, in which each thing is 0. Okay, I made this value. Now I'm just using the same code of memorization into tabulation just to tell you how to make your code optimal. Okay, now I have used a for loop and a DB. Okay, so let's code this up. Now I can use a DP of 0 equals to array of 0. It will just give base case, in which if I have only a 1, then it will always be a 1. Okay, now for I in, now I will do an ending. Okay, now this will be a ending point. Do I use an ending in this? No, it was a starting. Yeah, it was not an ending, it was a starting in this. Yeah, nothing worries about the variables. I in range 1 to n. Okay, I just changed the values. It was a starting point now. so I have to use the S for that, not to E. Okay, it's up to you how to use the variables. So in which now, suppose I am okay. Now suppose I am in this position in which E is this, and in DP there is some values of in this 0 and 0. Suppose this is DP and this is our array. Okay, now to make this optimal choose, I have to choose the values in this, so if I choose a sub array of this, then I have to do the plus of all these values and the sum plus of this value. Okay, so basically, or if I choose this value, this sub array, then I am going to take the value of this and the maximum into window size. Okay, this is main concept behind this. Okay, so and this I'm going to take in range from 0 to starting. Let's take these value as it is, these variables of copy and just paste this. Okay, I'm just erasing this because I have told you what these means. Now I'm going to take change the value. Now for s in range, now what will be the range? From I to I minus k. Okay, this would be the value in which I'm going backward, choosing the value that is backward. Okay, so suppose I am in here, then I have to choose here, then I have to choose here till k. Okay, so just copy. If now this condition should be reverse. Okay, and let's copy this and just paste this. Okay, to find the maximum in the window. Nothing to be tell you. And now the main part. This is how you should do the conversion of memorization to tabulation. You don't have to code yourself or think. Just replace all the values that need to be done. Okay, so this need to be done, and in this I have to you will tell me by thinking. Suppose I am in S position of this. Suppose I got this value, then what should be the DP? Should I take this DP or this DP? I have to choose this DP. So DP of S minus 1. Now the thing is, this could go to the -1 condition. If suppose I am here, then I have to choose this, so it would give a wrong. So if S minus 1 greater than or equal to 0, else 0. Okay, this is the condition. If S is not there in the DP, then it will return 0. Okay, then replace the DP of ending to this and return DP minus 1. The last, or you can say n minus 1, up to you. It will showing me, oh, it's not I, it's E. Sorry. Yeah, it's running acceptable. Yeah, it's done. More faster. Okay, this is the memorization code. Okay, this is all the memorization code, and this is all the tabulation code. so small. Okay, that's all for the video. Hope you like this. Thank you.